We're looking at viral abundance slides. This protocol was developed by Rachel Noble in 1999 as part of her PhD thesis, and it uses a stain called SYBR Green, which creates a halo around the virus so that it can be visualized using a microscope. Usually viruses are too small, but this stain has a really big halo, and so it allows us to be able to count them on the microscope. The protocol starts, first we have to make a dilution of the SYBR Green stain. We do a 1 to 10 dilution of it, and we typically make up about enough for the slides that we need. So we'll make up maybe about 50 microliters of it. So you take 5 microliters of the stock and you mix it with 45 microliters of Q water to dilute it down. You also need to thaw out the prolong, which is the mounting media, which has an anti-fade aspect of it as well. So that's the start of the protocol. You also need to thaw your samples. So the virus samples are fixed with 1% formaldehyde and stored at -80 until we use them. So we grab them out of the -80, we thaw them, do a quick thaw using warm water, and then once they've thawed, they're ready to be used. How our protocol typically sets up is we put on a backing filter, which is about 0.8 microns to create even distribution across the filter. The actual filter is 0.02 microns, and it's kind of this glass fiber type of filter, which is very fragile, so it's very easy to break them. So we put the backing filter on first, and then we put the 0.02 filter on top, and then we use the filtration rig to filter 3 mils for surface in the open ocean and 5 mils when we go a bit deeper. We filter it through. While it's filtering through, we then do a further dilution of the stain. So the working stock of the stain is 2.5 microliters of the already diluted stain and 97.5 microliters of 0.02 micron filtered Q water to ensure that there are no viruses. And it's 100 microliters, and we just pipette it into the bottom of a Petri dish, and it's kind of has this dome of a bubble basically in the middle of the Petri dish. The filter goes on top of this bubble, so the stain is absorbed through the filter, and we incubate it in the dark for 15 minutes so that the stain goes through and stains the viruses. We don't want too much stain because it would just become all orange on the microscope, so we just want to make sure that we have enough stain on the viruses so that we can see them. Then after 15 minutes, we then take the filters out of the Petri dish using forceps. We get the stain off the bottom along the edge of the Petri dish, and we put it on a labeled slide. And then in order to prolong the life, because these slides don't last very long, we use Prolong Gold, which is a anti-fading mounting media. We use 30 microliters of that. We put it on a 25 millimeter cover slip, and we invert it and put it against the filter, so the filter is kept basically preserved until we image. We usually go on the microscope and image the same day or the next day, just to make sure that it's as fresh as possible and we get the most accurate count. Once we get on the microscope, we take 12 images of each of the samples or each of the filters on the slides, save those images, and then we do image analysis using Image Pro +7, and the computer program has an algorithm that helps count the viruses. We count all 12 images, and then we throw out a high and a low. And then we enter the data into a spreadsheet, and we find out how many viruses were in the sample.